During the war, Germany manufactured vehicles for specific tasks. Heavy models were built, with varied engines and designs adjusted to each function. Each unit was produced following military orders, with parts assigned by the regime's offices. The archives confirm the existence of complete series, experimental versions, and limited prototypes. All of them had their own propulsion, structure, and technical tests. Some were assembled in visible factories, others in hidden places. They went through adjustments, trials, and field verifications. They carried a serial number, assigned mission, and date of use. Everything was integrated into the Central Command's war plans. Decisions about materials, personnel, and deadlines were recorded in internal documents. There was no room for improvisation. Tanks, planes, and special vehicles left production under direct surveillance. Some were so heavy that they could only advance on adapted routes. What were the vehicles that the Third Reich manufactured under these conditions to fulfill specific functions at the front? The Panzerkampfwagen 8 Maus was the heaviest armored vehicle manufactured during the Second World War. Its design was born in the last years of the Third Reich, when Hitler ordered the creation of a combat machine that could not be stopped by any enemy. Weighing almost 190 tons and with armor up to 24 centimeters thick, the Maus was presented as a total solution to the German military collapse. It was developed by Ferdinand Porsche, whose original design grew into an excessive project that exceeded the technical and logistical capabilities of the time. Its hull was armed with a main cannon of 128 mm, accompanied by another of 75 mm and an MG-34 machine gun. According to the plans, it could destroy any enemy vehicle at long distance without suffering damage. But its mobility was minimal. On favorable terrain, it barely reached 13 km per hour. It could not cross normal bridges, and its transport represented a strategic challenge. It was even proposed that another Maus provide it with electrical energy from land so that it could advance underwater using a breathing tube. The interior was suffocating. The Daimler-Benz MB 509 engine, derived from aviation, emitted intense heat a few centimeters from the crew. Vibrations were constant and visibility very reduced. Each maneuver required physical effort. Only 2 prototypes were built. One was used for tests without a turret. The other had a functional turret but never entered combat. Both were abandoned at the end of the war. One was partially destroyed. The other was captured by the Soviets and today can be seen in the Kubinka Museum in Russia as a combination of both models. The Maus never participated in real battles. Although 150 units were projected, manufacturing stopped with only 2 finished. Its maintenance was complex. Changing a broken track could take days. Its fuel consumption was excessive, more than 1,600 liters for every 100 kilometers traveled. In a Germany that was logistically collapsing, moving this vehicle from the workshop to a test area was a challenge in itself. Although it influenced some later designs due to its armament and resistance, the Maus never fulfilled its military objective. It was more of a burden than a solution, an immobile steel block that did not get to fight. Meanwhile, the regime's engineers also explored ways to break the limits of traditional flight. The Fokker-Achgelis Fe 223, developed by Heinrich Fokker and Gerd Achgelis, was the first helicopter to reach series production and operational use. It had a Bramo 323 radial engine of 1,000 horsepower that drove 2 rotors mounted on sidearms, an uncommon configuration for its time. This structure offered unprecedented maneuverability for rescue tasks, cargo transport, or evacuation in mountainous areas. During trials, the Fe 223 demonstrated that it could fly at more than 180 kilometers per hour, reach more than 7,000 meters of altitude, and lift 1 ton of weight without losing stability. Its body was made with welded metal tubes covered with fabric, which facilitated repairs. For pilots accustomed to conventional airplanes, this machine offered new possibilities: vertical takeoff, hovering in the air, maneuvering in narrow spaces, or landing on uneven terrain. But the helicopter also had weaknesses. The engine presented frequent failures, vibrations were intense, and the transmission system required constant revisions. Although the Luftwaffe intended to produce it in large quantities, Allied bombings destroyed the Delmenhorst factory in 1942. Later, attempts were made to resume manufacturing in other plants, but the lack of materials, personnel and logistics made it impossible to continue. Only about 20 units were produced, of which very few became operational simultaneously. Some were used to transport aircraft parts, recover damaged vehicles, or evacuate wounded in regions inaccessible to trucks or planes. In one operation, an attempt was made to rescue a crew trapped on Mont Blanc, but the assigned FA-223 crashed due to a malfunction, killing all occupants. It also operated in the Balkans and the Alps. Despite its capabilities, the lack of infrastructure and the unfamiliarity with its tactical use limited its impact. At the end of the war, several incomplete or captured models were analyzed by the Allied powers. One was taken to France and served as the basis for the development of the C-3000 helicopter. Others were examined by the United States and the USSR, which identified technical advances in its design that would influence later projects. The side rotor system, the lightweight frame, and the internal mechanics were studied in depth. The FA-223 did not change any battle, but it did open the way for vertical aviation in the following years. In a completely different field, the Third Reich opted for an automatic unmanned retaliation weapon, the Phi-103, known as Vi-1. It was the first guided bomb launched at long distance. Its rhythmic hum, similar to a motorcycle engine, anticipated the most feared moment: silence. When the noise ceased, it was because the bomb was falling. Designed by Fieseler with an Argus pulse jet engine, the V1 was 8 meters long and weighed more than 2 tons, with almost 850 kilos of explosives. It flew at an average speed of 640 kilometers per hour and at a low altitude to avoid radar. Its navigation system was simple: a gyroscope, a barometric altimeter, and a propeller revolution counter. Upon reaching the programmed number, the engine shut down and the bomb descended. The first operational attack was carried out on June 13, 1944, with London as the target. In just 3 months, more than 9,500 units were fired. Although most were intercepted or failed, about 2,400 managed to impact, causing thousands of deaths and spreading panic. When the Allies destroyed the platforms in France, the Nazis adapted Heinkel He 111 bombers to launch them from the air. This is how other cities such as Antwerp, Brussels, and Liège were attacked. It was even considered to convert the V1 into a manned suicide weapon. Models called Phi-103R Reichenberg with a cockpit were manufactured and volunteers were trained, but they were never used. The project was cancelled before entering combat. Despite its innovative design, the V1 had limitations. It was predictable, slow, and easy to intercept by fast fighters such as the Tempest or the Mosquito. In many cases, British pilots pushed them with their wings to divert them without firing. Barrier balloons and anti-aircraft artillery were also used. Even so, its psychological effect was devastating. It was a weapon that did not differentiate targets, had no pilot nor prior warnings. Just noise, then silence, then explosion. After the conflict, the Allies studied its structure, and several German engineers were transferred to missile projects in the United States and the USSR. The concept of an autonomous cruise missile was born with this bomb. It was a rudimentary device, but it marked a before and after. Although it did not win battles or alter strategies, it did change the way of understanding modern warfare. A machine without a crew, launched from afar, capable of impacting without prior warning, a tool of fear with wings. The idea of launching unmanned machines from long distances was only part of the race to dominate the sky. While automated bombs were being fired at cities, German engineers were working on something much more ambitious, an aircraft capable of leaving all enemy fighters behind. Thus appeared the Messerschmitt Me 262, the first operational jet fighter in history. Its development began before the war got out of control, but technical problems, material shortages, and misguided political decisions delayed its entry into action. Despite this, when it finally flew, it marked a before and after in aerial combat. It was equipped with 2 Junkers Jumo 004 engines, which allowed it to reach more than 850 kilometers per hour, far above any propeller plane of the time. Its design was advanced: swept wings, landing gear with front wheels, and an aerodynamic cockpit. Its speed gave it an advantage over any bomber, and its 4 Mk 108 30mm cannons could shoot down a B-17 with a single burst. In addition, some versions carried R-4M rockets, which made it a threat against entire formations. But not everything worked as expected. Hitler insisted that the Me-262 should be used as a fast bomber, which forced design changes, additional tests, and a deviation from its original purpose. Meanwhile, airfields were constantly bombed, and many fighters were destroyed on the ground before taking off. Although more than 1,400 units were produced, only about 200 were operational at the same time. There was a shortage of trained pilots, spare parts and fuel. Even so, the units that used it achieved significant shoot-downs. Pilots like Galland, Barkhorn and Baer integrated a special squadron with these fighters. They demonstrated their potential, albeit too late. The aircraft had weaknesses. The engines were fragile and their lifespan was very short, barely 25 hours of flight before requiring replacement. In addition, they responded slowly to the throttle, and any sudden maneuver could damage them. Pilots were not accustomed to these characteristics, which complicated their use in close combat. At low speed, the Me-262 lost its advantage. However, if it managed to maintain its momentum, it was practically untouchable. When the Me-262 entered the scene, Allied pilots reported encounters with German jets that were impossible to follow. This forced a change in tactics and reinforced attacks on airfields. Although its impact was limited by the circumstances of the moment, its design directly influenced post-war fighters. Models like the F-86 Sabre or the MiG-15 inherited several of its characteristics. The Me-262 was a combat tool ahead of its time that arrived when it could no longer change the course of the conflict. It was a promise fulfilled late, in a scenario that no longer offered room for maneuver. While the Luftwaffe was betting on speed in the air, the German Navy was planning something equally revolutionary underwater. The U-boat Type 21, also known as Electroboot, was the first submarine designed to operate submerged for long periods. Unlike previous models, which were essentially surface ships that could dive for a short time, the Type 21 was built to move completely submerged for days, at high speed, and without the need to constantly surface. It had an aerodynamic design that allowed it to move at 17 knots underwater, almost double that of its predecessors. It incorporated 372 batteries powering electric motors and a snorkel that allowed the diesel engines to operate without surfacing. Its hull was welded, not riveted, which increased structural resistance. In addition, it included rapid torpedo reloading systems that allowed it to launch 6 projectiles in less than 20 minutes and be ready for a new attack in just 5. For the crew, the interior represented a leap in comfort and efficiency. There was more space, advanced automation, and the real possibility of detecting, attacking, and escaping undetected. In tests, the Type 21 demonstrated that it could approach a convoy, fire without surfacing, and disappear without a trace. But in practice, very few managed to do so. Although more than 100 units were built, almost none entered real combat. Manufacturing was rushed, divided into modules in dispersed factories, which generated assembly errors and technical failures. Many of the first units required extensive repairs before they could be used. Only 2 Type 21 submarines carried out patrols. One of them, the U-2511, managed to get into position to attack a British cruiser, but received the ceasefire order before launching its torpedoes. The other, the U-3008, was captured and used by the United States Navy after the war. Although they arrived too late to influence the conflict, the designs of the Type 21 were copied by all powers. Later submarines in the Cold War, such as the Skipjack or the Foxtrot, took this German model as a reference. The Electroboot was a technical revolution that failed to materialize at the moment it was most needed. Its legacy, however, extended for decades. It marked the end of submarines that depended on the surface and the beginning of a new era of underwater warfare. It was an efficient machine, designed with vision, that lost its opportunity by arriving too late and in the midst of chaos. In that same context of desperation, but with even more radical ideas, emerged the Lippisch P.13A, one of the strangest projects conceived in Nazi Germany. Designed by Alexander Lippisch, the plane had a tailless delta wing shape and was powered by a ramjet engine fueled by pulverized coal. It never flew, but its design was so different that it attracted the attention of all the countries that learned about it after the conflict. The engine was based on the Kronach-Lorenz system. A rotating mesh basket contained the coal, which ignited once a certain speed was reached. Hot gases exited the rear, generating thrust. It was estimated that it could reach speeds exceeding Mach 2.6. The aircraft did not have common landing gear. It used a metal skid for landing and a disposable trolley for takeoff. Its cockpit was integrated into the vertical fin, and its structure was mainly made of wood and steel, allowing it to be built with accessible materials, even in a Reich on the verge of collapse. The project was conceived as a fast, short-range interceptor to attack bomber formations. At first, it was thought that it would ram enemies with its reinforced structure, but later it was considered to add conventional armament. Despite wind tunnel tests that demonstrated its aerodynamic viability, the aircraft never progressed beyond the prototype. A full-scale glider, the DM-1, was built to verify its flight behavior. That glider was captured intact by US forces and transferred to their territory, where it was evaluated by the National Advisory Committee for Aeronautics, predecessor of NASA. The design of the P.13A influenced the evolution of supersonic aircraft during the post-war period. Its shape, concept, and focus on new forms of propulsion served as a basis for study. It was an extreme attempt to adapt available resources to an urgent need. Although it never became a weapon, it did leave its mark on the development of aviation. It represented the mix of desperation and futuristic vision that marked the last years of the Third Reich. A plane made for a future that never arrived. The design of the P.13A was a clear example of how far German technological urgency could go at the end of the conflict. But while futuristic ideas that never took off were being tested, the regime also tried to develop conventional aircraft with strategic range. The most evident case was that of the Messerschmitt Me 264, intended to cross the Atlantic and bomb American cities. This model, known as America Bomber, sought to strike the United States with a single devastating attack, trusting that such an action could alter the perception of the war. Development began in the late 1930s, initially based on a reconnaissance project called P.1061. It was then adapted to a long-range bomber at the request of the Reich Air Ministry. The Me 264 measured more than 21 meters long and had a wingspan of 43 meters. Its landing gear was a retractable tricycle, and its fuselage included a glazed cockpit at the front. It was powered by 4 BMW 801GH engines, each of 1,730 horsepower, and had fuel tanks integrated into the wings, something uncommon at the time. The first prototype, designated V1, flew on December 23, 1942. It initially used Junkers engines, but these were replaced by BMWs due to performance issues. During testing, multiple difficulties arose. The aircraft was heavy, complicated to maneuver, and had limited performance when loaded. Despite that, 2 other models were built, the V2 and the V3. The second was destroyed in a bombing before completing its tests, and the third was never finished. The V1 was damaged by an air attack in July 1944 and never flew again. The project was cancelled in September of that same year. The idea was that the Me 264 could achieve up to 15,000 kilometers of range, enough to reach the east coast of North America from Europe. But in practice, flying that distance with a significant payload was unlikely. Alternatives were explored, such as using rockets to assist in takeoff or towing by other aircraft, but none were viable. It was also considered to use the aircraft for maritime patrol instead of the FW-200 Condor, but that proposal did not advance. For defense, the Me 264 incorporated turrets with remote-controlled armament and cannons on the sides of the fuselage. However, to reduce weight, the armor and number of weapons were limited. That made it vulnerable to enemy fighters. It never entered production, never flew in combat, and never met its original objective. Even so, its design influenced later aviation. The concept of integrated tanks, its cockpit arrangement, and its aerodynamic structure served as a basis for other post-war bombers. It was a machine built for a mission that was never carried out. Meanwhile, other German engineers were working on an aircraft with a completely different idea: to intercept enemy bombers at full speed from hidden runways with an explosive impulse. Thus was born the Messerschmitt Me 163 Comet, the only operational rocket plane in history. It had no propellers or jet engines. Its thrust came from a Walter HWK 109-509 rocket engine, powered by a mixture of 2 highly reactive liquids, T-Stoff and C-Stoff. Its acceleration was so extreme that it could go from 0 to 1,000 kilometers per hour in seconds. The Comet had no conventional landing gear. It took off with a trolley that was released upon ascent and landed with a metal skid under the fuselage. Initially, it was developed from the DFS 194 glider, transformed by Alexander Lippisch into a prototype with rocket propulsion. Its first powered flight occurred in 1941 and reached speeds of more than 800 kilometers per hour. In one of those tests, it even approached the sound barrier, which generated compressibility problems previously unknown. The combat version, Me-163B, was equipped with two Mk 108 30mm cannons. It climbed in a straight line, attacked at high altitude, and then glided back. But this tactic had flaws. The speed made it difficult to aim. In its first real engagement in July 1944, 6 Comets launched against almost 600 bombers and failed to shoot down any. The aircraft was too fast for its own firepower. An automatic system called Jagdfaust was attempted, which fired projectiles upwards upon detecting a bomber's shadow. It worked, but it was too late. The real danger of the Me-163 was its fuel. A leak, a bump, or an incorrect mixture could cause instant explosions. Many pilots died without seeing the enemy, victims of runway accidents, structural failures, or hard landings. The metal skid transmitted the full impact to the pilot's back. Even so, those who flew it spoke of a unique experience. They climbed up to 10,000 meters in seconds, but they knew that any mistake was fatal. Fewer than 300 units were built. Its squadron, the JG-400, achieved some shoot-downs. One of its pilots, Siegfried Schubert, shot down 2 bombers in a single flight, but died shortly after in an explosion during takeoff. Most of the Me-163 losses were not due to enemy fire, but to mechanical errors, accidents, or propulsion system failures. The aircraft ended up being a technical marvel without real application. As a weapon, it failed. As an idea, it was too risky for the conditions of war. The knowledge acquired in its development was valuable. The engineers who participated in the project later worked on advanced propulsion systems. The United States and the Soviet Union competed for the remains of the program after the war. The Me-163 remained a symbol of a technology that promised much, but proved uncontrollable in combat. An airplane that climbed like a projectile and glided down, without wheels, without margin for error. That same extreme spirit was also present in the Reich's most ambitious project, the V-2, officially known as a 4. It was the first long-range ballistic missile and the first object manufactured by humans to reach outer space. Its development began in the 1930s under the direction of Wernher von Braun, who dreamed of rockets to explore the universe. But the German army decided to use that technology to launch automatic attacks against enemy cities. The V-2 measured 14 meters, weighed about 12 tons, and was propelled by a mixture of ethanol with water and liquid oxygen. Its engine could generate 25 tons of thrust and reached speeds exceeding 5,000 kilometers per hour. It climbed up to 90 kilometers of altitude and fell in a ballistic trajectory with no possibility of being intercepted. Its explosive charge was 1 ton, and upon impact there was no warning or sirens, only explosion. The first successful launch was in October 1942. In 1944, more than 3,000 missiles were fired, mainly against London, Antwerp and Liège. In London, more than 2,700 people died from direct impacts. In Antwerp, another 1,700. Although its accuracy was low and its cost high, the psychological effect was devastating. The population could not defend itself. There were no fighters, radars or artillery to stop its fall. It was a supersonic projectile that arrived without noise and without possibility of escape. Each missile cost the same as a combat aircraft, and its production was complicated. It required scarce materials and coordination between multiple factories. Many were assembled in inhuman conditions in Mittelbau-Dora, where more than 20,000 forced laborers died in extreme workdays. At the end of the war, the military impact of the V-2 was limited, but its technological importance was enormous. The United States captured von Braun and his team, who would later develop the Redstone and Saturn V missiles used in the space program. The Soviets also used parts of the V-2 to develop their own line of ballistic rockets. The V-2 was the first step towards space flights, but also a warning. It was an unmanned bomb that fell from the sky uncontrolled. It never changed the course of the war, but it defined what future conflicts would be like. It was the first object to overcome the atmosphere, and also a tool of terror manufactured with advanced science in the midst of collapse. The V2 marked the highest point of German technological development applied to automated destruction. But even in its last months, the Third Reich did not stop experimenting with machines that bordered on the absurd due to their complexity or lack of practical sense. One of these projects was the Landkreuzer P.1000 Ratte, a supertank designed on paper by the Krupp company. Its name meant rat, but its size was anything but small. It was projected to weigh 1,000 tons, be longer than a soccer field, and operate as a mobile fortress on the battlefield. The P.1000 was to be equipped with 2 naval cannons of 280 mm mounted in a turret taken directly from the battleship Gneisenau, in addition to several smaller cannons and machine guns distributed throughout the hull. The idea was that it could destroy any ground target, withstand enemy fire, and break through defensive lines without external support. To move, it would use 2 U-boat diesel engines, and its frontal armor would exceed 25 centimeters in thickness. In theory, it could advance over any terrain. In practice, no bridge would support it, its speed would have been minimal, and its maintenance a nightmare. It was conceived more as a propaganda or symbolic piece than as a realistic weapon. Hitler showed initial interest in the project, but it was cancelled in 1943 by Albert Speer, who considered that the resources invested in such a monster should be directed to practical weapons. It never went beyond paper. No prototype was manufactured, not even a scale model. The Ratte remained an extreme example of how far the mechanical delusions of the regime could go. Another design that never got to roll was that of the Landkreuzer P.1500 monster, even more enormous than the Ratte. This project proposed mounting the 800mm Dora cannon, the same one used in Sevastopol, on a self-propelled platform that would weigh 1,500 tons. It was, in essence, a piece of railway artillery converted into a terrestrial vehicle. It was estimated that to move it a few meters, it would need a dozen submarine diesel engines working at once, with a fuel consumption greater than that of an entire squadron. There was no surface or structure capable of supporting it, and its manufacture was discarded before beginning. Albert Speer also cancelled it, considering that it made no sense to dedicate resources to an unmanageable machine. Neither a prototype nor a model was ever built. The simple fact that detailed plans were made shows how far the disconnection between the regime's technical ideas and the logistical reality of the collapse had gone. The monster was archived without protests, erased from priority lists, as a final symbol of engineering without purpose. While these ideas remained on paper, real vehicles with combined functions continued to be used on land. One of the most striking was the SD.KFZ. 2 Kettenkrad, a track motorcycle originally created to be launched from airplanes as a transport vehicle. It had a hybrid appearance between a motorcycle and a tractor, with a front wheel for steering and rear tracks that gave it traction on difficult terrain. It was designed by the NSU company and used an Opel engine of 36 horsepower. The Kettenkrad could reach 70 kilometers per hour, maneuver in mud, snow or narrow paths, and transport up to 2 people plus equipment. Its steering wheel was actually a motorcycle handlebar, which combined with the differential braking of the tracks to turn. It was used on multiple fronts, from transporting ammunition and towing light pieces to laying telephone cables on the Russian front. It also served to evacuate wounded or carry supplies in areas where trucks got stuck. Although its appearance was peculiar, its usefulness was enormous. It was not an offensive machine, but it was a vital support tool in environments where traditional vehicles failed. More than 8,000 units were produced. Even after the war, some continued to be used in agricultural or forestry tasks. Its simplicity, reliability and versatility made it one of the few Nazi vehicles that truly worked in extreme conditions without requiring constant maintenance. Another curious model was the Schwimmwagen, a small amphibious vehicle based on the Kubelwagen. It was equipped with a rear propeller that lowered to move in water and with 4-wheel drive for difficult terrain. It could cross rivers, deep puddles or flooded areas without stopping. Its design was so efficient that even the Allies considered it as a reference for similar models. It was produced by Volkswagen and used by reconnaissance units, sappers and commandos on special missions. Although limited in size and armor, it was a flexible tool in mixed environments. The combination of adaptability and simplicity made many German utility vehicles stand out more than the large failed prototypes. While engineers dreamed of supertanks or rocket fighters, what really worked on the front were the modest, well-thought-out and easy-to-maintain machines. But between those extremes, intermediate proposals also emerged, such as the Panzerjäger Tiger, P. Ferdinand, an armoured beast created to eliminate enemy tanks from long distances. It weighed almost 65 tons, had an 88mm PaK 43 cannon and frontal armour up to 20 centimetres. It was built on the chassis of the Porsche Tiger, a model rejected for the Tiger I tank. As dozens of these chassis had already been produced, they were adapted to create a turretless tank destroyer. Its baptism of fire was in Kursk in 1943. There it proved that it could destroy any enemy armoured vehicle before being hit. But it also showed its weaknesses. It did not have a frontal machine gun, so it was defenseless against close infantry attacks. In addition, its weight made it difficult to maneuver, and its maintenance was complicated. Many were put out of action not by enemy fire, but by mechanical breakdowns or getting stuck. After Kursk, several Ferdinands were modified with additional armour, a machine gun in the hull, and other improvements. This revamped version was called Elephant. It participated in the battles in Italy and on the Eastern Front until the end of the war. Although no more than 90 units were produced, its firepower and resistance made it one of the most feared tank destroyers. Its silhouette was unmistakable. It was slow, yes, but if it managed to position itself, no Allied tank could face it at a distance. Already in the last days of the conflict, with the Third Reich crumbling, another radical model appeared, the Sturmtiger, a vehicle based on the chassis of the Tiger I, but with a 380mm howitzer taken from the Navy. It was designed for urban combat, especially in environments like Warsaw, where buildings became fortifications. The Sturmtiger fired self-propelled rockets that weighed more than 300 kilos and could penetrate walls or structures with a single impact. Its cannon fired hollow charge or explosive ammunition, and its range was several kilometers. Only 18 units were produced, all built from damaged tanks that were reconditioned. In combat, it was extremely destructive but very slow and had low ammunition capacity. It could only carry a dozen projectiles. Each reload required an internal crane that placed the rocket inside the cannon, an operation that took several minutes. Despite that, when it fired, no building could withstand it. The Sturmtiger operated in Germany, Hungary, and in the defense of Berlin. It was feared by Allied infantry, but its presence was merely symbolic. It was more useful as a machine of psychological terror than as a strategic weapon. Even so, it once again showed the German approach of adapting any available technology to prolong an already lost war. Its combination of brute power and improvised design summarizes the final phase of the conflict. Where there was no longer time for new plans, what remained was reused. Until the last day, they continued building gigantic machines that, while impressive on paper, could not change the final outcome. This tendency to manufacture gigantic machines that no longer made any difference reflects the final state of a power that sustained itself only on technical ideas without logistical support. From absurd prototypes to useful support vehicles, the development of Nazi weaponry combined real advances with excessive projects. These were designs created in a race against time, with dwindling resources and decisions increasingly disconnected from reality. None of these vehicles on their own changed the course of the war, but all remained etched in the history of military engineering for the way they were conceived, used or abandoned under total pressure. That was the mark left by the most brutal vehicles manufactured by the Nazis.